In the examples so far, looping has been done in a brute force sort of way, that is, a subtraction statement reduced a counter, then a compare statement was used to determine whether the branch should be taken. But there are some opcodes that mimic the actions of a compiler and can be used to construct loops. For example, a loop can be constructed this way. The ECX register is used as a loop counter. The loop instruction at the bottom of the loop subtracts 1 from ECX, and if the result is not 0, it branches to the label. It's the same thing as was shown in the previous examples, except in this case the details are hidden. And there are others. This is the same instruction, except the test of a flag has been added to it. The instruction still subtracts 1 from ECX, and is still required that ECX is not equal to 0, but for this instruction to loop, the 0 flag must also be set. There are two mnemonics for this opcode. You can write it as loop Z for loop 0 or loop E for loop equal. And there is an opposite. This opcode decrements ECX and will loop only if the result is not 0 and if the 0 flag is not set. The mnemonic is loop in 0 for loop not 0, or it can be written as loop in E for loop not equal. In some of the earlier examples, the loops were set up as while loops. That is, the test was at the top. This is the standard form of a while loop. Variations are possible, as you saw in the previous examples, but mostly the test is made at the top of the loop. The other basic form is the do-while loop, or do loop, where the test is made at the bottom of the loop. This is a simpler structure, requiring only one label. In this one, the test is made at the bottom of the loop. The main difference between the two is that the do-while loop, the body of the loop is always executed at least once.